So I'm going to go over the assembly examples. I'm gonna try to go over as fast as possible. And I'm not gonna concern myself whether or not I understand. And I'm not gonna put these examples on x64 DBG because I think it's gonna take too much time. So I wanna finish this as fast as possible. And I'm probably just gonna highlight the ones that I think are different from most. So I have like a wide range to put the examples on Enki. Because the main thing that I want to do is put the C++ version and then the assembly version on the back of the cards, on the Enki cards. So I can train on Enki while I study other stuff. And probably not gonna put the... Maybe I will put this more complex examples here. But I'm gonna try to go as fast as possible in the beginning, and then if I go too fast and I finish fast, I'm going to probably spend time on the ones that I select to make Enki cards from. So I just want to finish this and continue the Godot stuff because it's been a long time since I stopped the main thing that I'm trying to do there. And then I'm probably gonna study or read the book on Haskell, and so I already understand the main concepts on Haskell now. So I think I'm gonna study off stream. I'm just gonna go one by one here. I don't remember where I stopped. I mean, maybe I should continue from this thing here. This is probably the last one that I did, overflow. And the problem with this example here is that I have to... They depend on the argument that is being passed there. But I guess the type here is the difference. Let's try to put larger value. I'm gonna highlight this one probably. Multiply large. I think between signed and unsigned, these ones are basically the same thing. They were the same thing. I think I'm gonna put the unsigned here. So I'm gonna stick with x86 for now. Then once I finish, then I might go back and do both. Basically pushes the value. It's interesting that it's pushing 0 here this time. Then calls the function stack prolog or epilogue +4. +16. Yeah, I'm just gonna move to the next one. Puts a smaller value here. So he's using idiv. That's ChatGPT. What is this? I do remember seeing this. I don't remember exactly what it is. Convert double to quad words. Value is 6. So it's basically using the two registers. Interesting. It's passing based on the offset. The A is probably the first argument, B is the second argument. It's pretty similar. I'm just gonna put this one there because it's the first division. That's the signed division. Unsigned probably doesn't have any difference. But it might be. If it is different, then I think I'm gonna put both of them. It is different. So this one uses the div and it doesn't use the idiv. So it's interesting because on the multiplication, both the multiplication and the sign and unsigned multiplication, it uses the imul on both. And I think I should do with compiler optimizations probably. And the main thing that changes between the examples, I think, is the type that I use on both. So, and I got these examples from ChatGPT. But I'm gonna put this one as well, since he uses a different one. I'm gonna move on to the next. I forgot to put the timer. Division with remainder. And this is also interesting. I think I'm gonna highlight this one as well, because it's just, and now he's using idiv and the other thing as well. Because it's like a different form of division, so I think I have to put this example there. It's very similar. So maybe if I, let me see what happens if I put a very big value. But I think in order to overflow, it should be extremely large. Because 64 bits is going to be a very large number. And I think it's not even, well, for division, I'm not really sure actually. No, I think that maybe depend. It has to depend on the type, obviously, because of the floats. So now it complains. But I think that the result on division is also the double the amount of the size of each number you use. So on multiplication, if you use 8 bits for, it's just gonna double the amount of bits on the results from the ones that you use to perform the operation. But division, I don't remember really well if it's the same thing. I think it is probably. Because the way that it works, I do remember seeing the circuits, but it's kind of confusing to understand as well. But it basically uses 2 different registers to do the division and then shifts the number, I think, each time. So it shifts and subtracts the number, and then the result's kind of like a cascade on the final register. So I do think that it uses more. It probably uses double the size. And that's why you need 2 different registers there. Yeah, it definitely uses 2 because of the instruction there. So it's interesting that this one doesn't use the CDQ, or however you say this. A CDQ. I was just gonna move on. It's kind of hard to, because I kind of want to put all of them, obviously, because each one has an interesting thing. But then my concern is that it's gonna be too many examples, and then it's gonna be hard to. So like maybe I will. I think it's probably a good idea to be more exclusive in the beginning, and just remove these examples that are kind of the same. Then I focus on the ones that I have there, and then until I really build the patterns, then maybe I can create another deck. So what I could do is just create another spreadsheet and put the remainder examples on that spreadsheet, and create another deck on Anki once I train this one that I'm building a lot. If I think it is gonna be like necessary or good. It might be better also after having this first foundation to get practice by looking into the executables instead. That might be a lot better. So this one has some jump instructions. I guess just because of the nature of the example here. So usually from what I've seen, the first jump instruction is going to be the else clause. So the compare subtracts the value you put here, so it's checking to see if this value is 0, which is probably the second argument, which is going to be this one. And if it's not equal, it jumps because it's the else. So the condition is b equals 0. So in order for this to jump, the comparison is going to set the ZF flag to 1. If the result is 0, which means they're the same. In this case, it's going to be 0, which means that this is going to jump. Because it's really jump if not 0, instead of jump if not equal. And that's the part that is kind of confusing. So I'm going to look into the picture there that I have for the jump. ZF equals 0, basically. It's getting kind of easier to remember everything. I'm gonna put this 2 here, I think. Then put this thing here. I need 3 numbers. I think the toughest thing about learning assembly is not really like I think I already got the fundamentals down. The problem is how do you reason about the variables on assembly? I think that's the challenge. Because you're gonna lose information from the higher level languages through assembly, obviously. Otherwise, it would be pointless to create higher level languages. So, like, once you understand the jump, mainly in the function call, I think everything else doesn't matter that much because it's just going to be an abstraction that builds on top of that. So the version of assembly is just going to be a mix of the same fundamental patterns. So there isn't really much you can do to clarify. Maybe, yeah, I think that this thing that I'm doing now is probably the best thing to do because it helps you to have like a pattern matching based on the examples. Like you have like hopefully that's what's gonna happen. I'm gonna be able to visualize what it looks like for from a higher levels language perspective. But even that situation, I think like there isn't much you can do because it's gonna depend on the context. So like you're never gonna be able to accurately see what the coding assembly is supposed to be on the higher level language because of ambiguity. So I think after this first stage that you understand this like fundamental things, is more about understanding how the addresses work usually, and what happens when the variables like how do you keep track of the variables and how do you make sense of the fluctuation of the values on memory, and like how to reason about what exactly is the program supposed to do, like what is the purpose of the program. I think this is very hard to like. It's kind of more intuitive on higher level languages because it already has the embedded assumptions of the people that build the libraries and stuff like that. And this is usually going to be the main problem anyway on writing code. I think that's the whole skill is about debugging. It's about clarifying the black boxes that you get based on the stacked assumptions that become black boxes because of the way that abstraction is built. So the whole skill is going to be the whole skill is becoming better at clarifying the black boxes because it's going to help you to debug faster. And I think that is easier in a way because you do have this like intuitive notion of what the program is supposed to do. But on assembly, it's not very easy to think about this because like obviously for a simple program it doesn't matter that much. It's like not interesting, like just printing a character on the screen, for example. you can easily understand, like it's gonna call a function and it's gonna call interrupts on the hardware, and there's gonna be uh, either on the operation system. I think that's no, it has to be on the hardware actually. So it has to be on the instruction set architecture. The instructions that are gonna be encoded to set to allow you to print stuff. But obviously you're gonna have abstractions from the operation system that are gonna make it easier to use the interrupts, and some situations you need to have kernel access to be able to call the functions. But it's not that interesting to understand these programs because they don't have anything that they do in practice, like besides printing useless stuff to the string. So the most interesting thing obviously is going to be stuff that allows you to visualize or is very complex. And then this is kind of the paradox, because once the complexity, I think the complexity scales exponentially. So, but it's kind of, it follows the Pareto distribution. So I think it's more about, after you get the fundamentals, it's more about learning the fundamental functions that the operation system uses and the fundamental addresses that are used most of the time, and then clarifying the structure of the kernel to understand more complex systems and how it's going to work on assembly, and also like create a system to visualize the fluctuation of variables. I think, but it's very hard to think about how to create a system to learn this. So like there is a gap between the. I think that the only way or the best way is probably to just use x64 DBG to spend a bunch of time going over the actual executables, trying to understand how it works, and then watch a bunch of videos and read the documentation to learn more about the kernel. So this one only calls once here, and I think, yeah, so it only has stuff related to, I think the pushing ECX is just by convention probably, and then it pushes to the stack the other arguments, and then it calls the function. Here is going to remove the values on the stack because of convention as well, so the caller removes the space after the function call, which is 12 because this is 32 bits, I think. It is 32 bits because it's using the E register. So E is 32 bits. And this is the weird thing about here that I couldn't clarify, but I'm not 100% sure if the x64 here is the 64-bit version of x86 assembly. And that's why I'm using this one now, which is 32 bits. Because this one I know is x86. But it's going to be basically the same thing, but it might be interesting to put this one because using the float register. I think the float registers are similar pattern than the normal registers from when it comes to the size. So the number in the end here, I think, is directly related to the size of the float, if I remember correctly. And there's also XYZ as well. So I think the X, Y, and Z are also related to the size. I don't remember now if there is like different numbers at the end there for sizes, or if it's just X, Y, Z. But I know for sure that X, Y, Z is related to the size. So I don't know the exact sizes, but let's say for example that XMM0 was for 32 bits, let's say, or something like that. Then YMM0 would be for 64 bits. And then Z is the double of that. But I don't remember about the numbers. If there is... And I'm not going to search for this now. So just gonna... I'm going to put this one there. Also, there's the other one here. So it puts the codes from the function here, but it doesn't call, obviously. Let's see this one. Operations. The float one is obviously interesting to put. I'm gonna put the float. It's different than the other ones. And also here is using this stuff here, which I think is usually the way that they allocate local variables. Like they allocate the offset here, or yeah, either offsets or addresses. So for floats, I think it's just these addresses here, and this DD is for, I think it's something related to data, but I don't remember exactly what it stands for. And then for the other variables, integers, they just pass offsets. I think it has to do obviously with the structure of the registers on the CPU. So I'm just gonna move on to the other category, stack frames. I think it's better to do one by one actually, and then try to go faster. Because otherwise it gets to too many things there. I think one by one and then going faster is probably better. Just calls the function. It's not very interesting. So I think I'm not gonna put this one because it's just similar to the other ones. Just using the offset here, -4, which means it's gonna be below the current base, which is the base of the stack. No, below, it's not gonna be below, it's gonna be above the base, because minus goes up. So it's usually the convention, I think, to have minus offsets for the local variables and plus offsets for the parameters. So the parameters are below the base pointer and the local variables are above the base pointer, and above is subtracting from the base pointer. So this A here signifies that's going to be EBP -4, and the square brackets is kind of like a dereferencing, so it's getting the address of the stack and pushing the value there, moving the value to that place on the stack. Just gonna move on to the next one. So same thing, subtracts here. I think subtracting to allocate space for the 3 variables. Then it's moving based on the offsets. Then it's adding operation here. Just adding based on the offsets and allocates. So basically the same thing. I'm not gonna put this one, it's not very interesting. Move on to the next one. Same thing, so I'm not gonna put, just gonna move on to the other one. I think these examples were probably the first ones that I did. So it's kind of unlikely that these ones I think is where it starts to get interesting because it's different than the previous examples. But I think this was probably the first file that I did before I did the other ones, and then I decided to separate them. So that's why it has the other examples there. And so I calls this one here first, and then calls the other one. I'm gonna put this one there, even though it's not very interesting, because it's kind of different. So I think it's probably good to have, but it's basically the same stuff. So the biggest difference here is gonna be that it's moving from the result to this place here. That is kind of interesting, because usually what happens is, I guess it's like it's moving to the result because it doesn't return anything. But usually what happens is that the EAX by convention is going to be the return. So I want to see what happens if I put, I'm going to put this example there. Let's call it. This is weird. Oh, it's because of the return. Yeah, so now it does the same thing. So it pushes there for the stack because the local variable, the result, but then it pushes again to the EX. Moves again, not pushes, but and EX is gonna be the thing that has the results usually. So I'm gonna move on to the other one. Let's modify. This one's probably gonna put as well. Because it's first time that there's a pointer example. This might be annoying. I'm not sure if I can pass like this. I think I should pass as no, it's not gonna let. Not sure if this is gonna work. So it doesn't work. Hmm. Think about this. I do remember on some other example I used something like the reference there, but I don't remember how. And it did work, but I don't remember what I did exactly. And this is probably not gonna work also. So see if this works. Yeah, nice. I'm just gonna do it the easiest way possible there. So it uses load effective address. There is a similar example before. I do remember. I think it's on the first examples on the if else. I'm pretty sure that there is, but I think I'm gonna put this one there as well because it's interesting. Well, the biggest difference between this and the other ones is that it uses load effective address because it's gonna use the address of the thing on the function. It's basically here. It's 42. Yeah, so it pushes it moves the address to the register here. And I think here is basically dereferencing. So he's using the square brackets, which is basically the dereference of the pointer here. Which means that it's gonna move the 42 to the like as a value on the memory location that is from EAX. Just passed as an address here. So this one pushes or moves the address of the base of the stack, which has the value here, I think. Yeah, so it's moving the value to that place in memory, and then it is moving the address of that place in memory, which is basically the base pointer. Is using the base pointer, which is the base of the main stack, to EAX, and then pushes that address to the stack, and then calls the function. So this 8 here is gonna be the offset from the obviously it's gonna be from the base, but I think it's gonna be on the place that the EAX is there. There has to be 2 rows because it's 4 bytes each row on 32 bits. And I think this is because of the EBP here. So this one moves 4 bytes, moves the ESP to 4 bytes, then it moves again when it pushes here. then it updates the base pointer to the current top, which is 2 rows above the EAX value that it has here. That's why this offset is 8. Because 8 is going to decrease the pointer, which is going to be below the current base. It's going to be the value there. Yeah, so I'm going to put this example. So, I'm probably going to put this one as well. It has the... Because it has the recursion for the first time, I think. So here calls again. It's not that interesting, but I think it's just because it's different, I'm gonna put there. I'm just gonna move on to the next one. Trying to go very fast because usually I spend too much time on each example. So I wanna make sure I cover as much ground as possible. Is this? So this obviously I'm gonna put there because it's the first struct example. And the thing is, for these kinds of things, I think it's gonna be like there isn't gonna be much that I can do. I'm gonna have to use x64 or IDA to see this stuff because it's very different the way that you see here and the way that you usually see on the debuggers because they're gonna put the structs on different places. But I was curious to see how it's going to use, but I guess it's not using. But it's kind of weird that it's not using here. Like it's a unique address in memory. Sure. But I guess it's just because it has true values. So like it probably changes if you're using malloc or something. Yeah, because I think that's since I'm not using malloc, it's gonna allocate this stuff on the stack. So if you use malloc, it's gonna allocate it on the heap, and then it's probably gonna have another place here. But it's gonna be probably similar to these things here, where it's gonna put addresses on memory. And then I think it calls a function from the library, and I think it probably doesn't show the code for the library, but I'm not pretty sure that on the other examples there I have some that uses malloc. Yeah, so it's basically just moving to the stack. It's like basically the same. And there isn't obviously like there isn't the concept of a struct on assembly. So like the information happens on the compiler. So I'm gonna put this one there. Final one. There. This one I'm gonna ask ChatGPT because I think it's easier. Probably have to use malloc. What if I pass like this? Oh, is the function. So maybe if I pass like this again, it's gonna work. Yeah. So it's the same, like similar pattern from the other examples, just gonna use load effective address when you're passing a reference. Because obviously you're gonna need the address and then use the square brackets later to show the reference. Basically the same thing. I'm gonna put there anyway. But the thing that's kind of annoying is that these examples don't really, or maybe it is just as simple as that. But I do think that's, like I said, on the examples that I use, this goes back into the point that I was talking about, where it's like the challenging part is bridging this gap of the complexity. Because like if I'm gonna see something, the ideal situation would be to visualize what happens when I'm using Godot, for example. But then it's gonna have like 70,000 libraries involved to allocate memory and to do a bunch of other stuff. So you kind of lose the. It's not very simple to see how it works on assembly. So obviously you can use a malloc, simple malloc example, but I still think it's not gonna give justice to an actual executable from a complex project. So I think that for these kinds of things, it's probably there isn't a much better way yet to figure this out. You kind of have we have to use a debugger, and then just based on experience, you become better at understanding how usually it's gonna allocate memory and deal with stuff. So I'm gonna move to the next thing. Next one is complex type arguments. I think this one is gonna be very similar to the other ones. Actually, not sure how should I put this. This is kind of interesting because of the char there. I think yeah, you can only pass one letter. That's so this one. So it's probably this one. I'll just move into this stack. I'm gonna put there because why not? Move on to the next one. It's gonna be similar to the other stuff. I think this one is probably not worth it. Should put actually it might be because of the structure of the struct. Actually, it is different. It's very different because of the structure of the struct. So this one is allocating more things. I think just because of the values there. And this one is using the security cookie, which is kind of interesting. So I'm definitely gonna put this one. I've seen this one a lot, the security cookie. So I'm gonna ask ChatGPT. Buffer overflows. Mm. So it's kind of like a flag that if you overflow the buffer, it's going to probably throw an exception or something like that. Yeah, trigger an exception. Interesting. Okay, so I'm pretty sure that I highlighted here. I'm gonna move on to the next one. Hmm. To this source. As kind of similar, obviously. The main difference is gonna be the load effective address. I think I'm not gonna put this one because it's just the same thing. And I kind of already understand, like, not I kind of already understand how this works. So whenever you see load effective address, very likely that there is a pointer being used. So you're passing a reference to a function, which is very good to know. So I want to move on to the next one. So pass large struct value. Should it is. Yeah, I don't think this one is that interesting because it's basically the same. Actually, it is interesting because of the memsat here. I think this is the first time that I've seen this memsat call. Hmm. And also this one here. I'm definitely gonna put this one there. So large struct. And it's calling the function here. So obviously all of this I assume is the initialization of the thing. So it probably starts allocating here. So EAX. Very interesting that it passes this security cookie to EAX and then XORs with the base pointer. So the XOR usually is going to be used for encryption based on what I've seen. It's like it's not it is used on encryption algorithms. I don't remember where I remember that I took the note, but I don't remember. Maybe it's here, this folder. I think it is here. Yeah, XOR is usually used on encryption algorithms, so it makes sense. They're masking with the base pointer, so it is like ChatGPT send there. They move this value to the EAX, and then they XOR based on the base pointer, and then they're gonna move the result to this array pad here. It's kind of like randomizing the starting point of the array, I think. Starting point of the address. I think that's pretty sure that this is why they're doing this here. So I'm gonna have to spend a bunch more time on this after I move everything. and probably spend a bunch of time asking ChatGPT as well, because what is interesting to me is understanding how they are gonna remove here. So like how do they achieve symmetry to know how to clean up the value. So it's probably with this function here. Here they're doing the XOR again, so it seems like that it's just the symmetry. So here they're cleaning up the stack. But it's interesting to think about like how do they know how does this work? You have the initial security cookie, then you apply the XOR, then how do you know how do you get the same value on the end here, the function? Yeah, so that's so I'm gonna move on to the next one. So array by reference. Hmm. Actually, I think it's probably since I don't wanna think about this, just use the same value from the other example to create a pointer. I think this one's gonna be similar to the other ones. There is also the security check here, so I'm not gonna put this one there. I'll be right back. So this one is just similar to the other one, so I'm just gonna move on to the next. Let's go. I'm gonna put this one because it's just a class. It's very similar to the other one for the struct. It just seems interesting because it is a class. So later, probably, I think after I finish with this, I have to focus more on the Godot stuff until I finish the scene. But probably once I finish the scene there, the beginning, I'm gonna have to go back to this. And then once I go back, I spend more time to see if I understand the. So like I'm gonna spend more time on these specific examples that I think are interesting to see if there is a to contrast both of them to see if there's a difference. And then maybe I can put both of them on the same thing there, the same code here, and then compare. See what are the differences between. But like I said, I might change my mind about this because I'm not really sure if it's gonna be better to try something else. Because the main problem, like I said, with this thing here is that it's not an actual program. So the functionality is not in the context of what it would usually happen on a normal situation. So I'm just gonna put this one there and move on to the next. This one I think I'm gonna have to put because by convention there is a certain amount of arguments that I think it's 4 arguments are passed into registers, and then beyond that you push through the stack, and then it's gonna depend on which compiler you're using. So conventions change. That is interesting because of that. But I think for this, I'm just gonna do for MSVC, otherwise it's gonna be too confusing. On the Anki cards, you put like a bunch of different variations, because then like you kind of lose. I think it's just too much to focus. Let's see, 1, 2, 3, 7, 6, 5, 6. Yeah, here like this is kind of the downside of doing this here. Because you're just pushing everything on this stack. So based on the nodes that I have there, in the first one I think is gonna be on ECX, if I remember. And then the other one is gonna be on the EDX. First 4 parameters from left to right are put into RCX, RDX, and then R8, R9. Remaining pushed onto the stack. So let me see if I test this other one here. It's also putting on this stack. See this. Yeah, now it's using the. So I guess I should change the example there. Let me see if there are other variations. So this mix of arguments. Yeah, there isn't. So I'm gonna change this example so that it has it is like this. So I think that the reason why it's probably some compiler thing where if you call a function directly from main, it just pushes everything to the stack. But when you're calling, yeah, it's probably because on main it doesn't consider that there's a caller and a callee, maybe. But when you have a function that calls another function, then it's gonna follow this convention. So I think here is like moving on the opposite uh, way, let's say. I think that I wrote this here as well, or from left to right. Yeah, but I think because of the nature of the stack, it goes on the other way. So it moves first the R9 one. It moves these ones onto the stack first, and then moves to R9, R8, EDX, and ECX. Yeah. So I'm gonna I'm gonna create another one. So here's probably gonna be similar to the other thing, where it would be better to call this function from another function. But I think this one I'm gonna leave it like this, because there's a lot of stuff there, a lot of code. And it's very interesting that the function doesn't do anything here. Like it moves these values, but like the thing that is kind of weird to me is that there is obviously 7 arguments that is passing, but it's only moving this, like only moving 4. So I wonder why it's doing this, since the function doesn't do anything. It's probably related to I think these values are probably the values on the struct, or related to the structs. That's the only thing that would make sense. Yeah, but it is weird, like if it was that, then it would be the same time for, like would be true for each. Makes sense. Or maybe because it's not the function doesn't do anything, some convention that it moves only to the arguments to the registers. No, but it's moving from the registers into the stack. So it doesn't make a lot of sense. It's moving the first 4 here. So, okay. So it does have different values for the number. I'm gonna put this one obviously there. That's mix up arguments. But I'm gonna have to spend more time, some other time to figure this out. So I wanna go fast to make sure that I get all of them, because I don't have a lot of time and I have to do a bunch of other stuff. So I don't want to spend too much time on this. So it looks like it's gonna be passing both 50 and 8,000 there. I think it's probably just the first arguments that it uses here. It's RD8, it's 20. Yeah, so it's gonna be the first 4 that is moving from the registers to this stack here. I think it's just by convention that it moves, and probably if you put some optimizations, it's gonna change the outputs. So I'm gonna move on to the next one. Let's pass class constructor destructor. Yeah, this one obviously is interesting because it's different, so I'm just gonna put there. But there isn't that big of a deal. Like it's not. You're just calling the function, the destructor. I think most of the complexity obviously is gonna come from the compiler and not from the assembly when it comes to this stuff. Because there's gonna be like a bunch of optimizations on the compiler that structure the assembly code based on the life cycles of each thing. I think for these kinds of things, it's more interesting to see the comparison between different languages. So it would be interesting to see one example from Rust and then example from C++. Because on Rust they have lifetimes. So, but I think it just takes too much time. So I'm not gonna do this. So I'm gonna put this one there. It's interesting that it's not just calling the destructor here. Oh no, this is the main function. So the main is here, so it does call the function. Yeah, here is just the. Actually, I'm not really sure if it's the label. I don't know where does it call this from? I'm gonna move on to the next one. So maybe I should pass that thing. I think that there is another similar one already, so I'm not gonna put this one there. I'm just gonna move on to the next one. That's function pointer. Yeah, this one's gonna be interesting, I think. I'm gonna have to ask ChatGPT to see how can I pass this. If I have to use standard library or something. I didn't think I can pass like this. Oh, easiest thing to do, just call. Just use ChatGPT. It's supposed to work like this. Oh, it's because of the wrong function. I need this- oh, nice. The interesting part is this thing here. So this part's different because of the way that is loading the pointer. So for the other situations, it just uses the square brackets and uses load effective address to pass the reference and the square brackets to the reference. Well, this one is using this offset flat, which is interesting. Also, I could put more examples as well for the class inheritance, but I think that's gonna be. It's not worth it to do this now. I think it's probably better to just like focus on the fundamentals a lot first and these basics. Then once I have like very like on the unconscious, then I move on to the other stuff. Because there's so many other things to do. I think it's not very good idea as well. To just do a bunch of other examples. I'm gonna move on to the next thing here. Generic. I think these were the first ones that I did there. So for these ones, I probably maybe it is actually good to put this. I think that's I'm probably gonna put all of this. So this one, because in the beginning I was putting everything on one function, I think. Just see all the variations of everything. And the problem with these examples, I think that's is not gonna be very good on the on Anki cards because it's just too big. So it's probably not very good. I think that's the reason why I did the other examples. Just separate into smaller functions so I can put on the Anki cards. Yeah, so I'm just gonna move to the. I don't think that makes sense to put this one. I already have like most of this, probably all of them, at least one example of each operation here. On the other examples, obviously it's gonna be slightly different because I think for the bitwise ends and R, I only have on the if-else situations. But I still think that's like for Anki it's not gonna be very good to put this thing here. I'm just gonna move on to the next one. I have to copy the structs. Yeah, I think that like these examples on the generic, they are better to spend some time studying on the thing and not with Anki cards. So I'm probably not gonna put this one there as well because there's too much stuff. But it is very interesting here. So this is the stuff that I was imagining that is gonna happen when you're. I mean, maybe it's because I changed the compilers. Just realized this now. But this is more what I was thinking that was gonna happen in the other examples of the class and struct. That it creates all this like these separate uh, places where it initializes the data for the struct and the class. Then it's gonna use these addresses to on this stack there. There's a lot of code. It's probably because of the libraries there that I'm including now, so that's probably the biggest difference. I'm gonna remove the libraries and the functions that use the libraries, just see what happens. And there's also some virtual thing there, a virtual keyword here. So I guess this comes from the libraries there. It's probably because of that is very different. It might be annoying because of this stuff here. Let's remove everything. I think I removed the constructor by mistake. Yeah. It's because of the string there. Yeah, so now it's a lot more similar to the other examples. I think probably the biggest difference was the libraries there. I think once you get, or once you're using libraries, it might be because the libraries use the heap, but I think once you use libraries, it probably uses the other parts there. So I'm just gonna move on to the next example. Maybe print message. And maybe there are some examples that are not very, but I think that this is gonna be the same thing there. This is gonna be too much stuff because it uses the library. That should be both probably because of the string. So, yeah, so can't really put this one because of the libraries, but this one confirms that the other one was different because of the libraries. So I do know. So I'm gonna ask ChatGPT what is the stuff here, but I do know that this is for allocating variables and stuff like that. I've seen on the some assembly codes from the Godot's compilation, you basically do the same thing. But I don't know like when the compiler decides to do this. What is the point that determines the heuristic that determines that it's gonna use this stuff instead of allocating stuff on the stack? Definable words. I wanna see what happens when they change the compiler. Show the other one. It was basically the same stuff. Yeah. Remove this. I'm not gonna put this the other examples just because it doesn't make sense for the Inky cards. So I'm just looking if there is gonna be one of these that I can put there. So why it doesn't do anything here? Interesting. Oh no. Ah, so it doesn't put anywhere because it doesn't. Let's see if I can do this. Hmm. Call function. I should probably put this there. I think I'm gonna put at the end there, just because it's different. I copy stuff. So I'm gonna move on to the next one. Let's execute a function. I think this is gonna be basically the same thing, same problem as the other ones. Yeah, I'm not even gonna do this one because I know that I'm gonna have to use the library there. So maybe it's interesting to change the pointers so I can pass anything. But it's gonna be the same one that I already did, so I'm not gonna do this one. I'm just gonna skip. And this is gonna be basically the same stuff, but I'm gonna put there just to see. But it's not very interesting. It's just gonna be using load effective address. And I'm gonna remove this as well. When it comes to these examples, I think the other ones that I already did are probably better to use. I just use this load effective address. So I'm gonna move on to the next. I'm not even gonna do this one, just because of the standard library there. I'm gonna put this one and I'm gonna remove all the stuff that uses, because it might be interesting. I think this one I have to put inside of the main and then delete. I have to remove everything that is gonna use a library. I think it's not worth it to put there, because it's basically the same as the evals and branch conditions, and then the pointers. It's not using load effective address here. It's slightly different because the pointer comes from the main, I think. So this is a local variable. It's moving 0 to the top. So here's comparing argc, which is 8 plus 8. I don't understand very well what is argc supposed to be. I think it is the value that exists there, and that there isn't anything. Argc is going to be the number of arguments that are passed, but I don't understand how it's going to work on the, like how they're executing this under the hood. But obviously this address here is going to be 8, so it's going to be, and I think it's 8 from the offsets of the base pointer. So like the value here is going to be the same value here, so it's like basically the top, so it moves 0 there. So this is the I variable. And then it jumps here. So here has 0, but this one is going to be plus 8, so it should be on the value before it subtracts there. It's basically on the last CSP, last stack pointer, but I think it is moving the value, not the address, or comparing the value, not the address. So the question would be, what does it have there? I think it's just 0. But yeah, for this example, it would be better should you go over with the x64 DBG to see whether or not it's going to jump. I'm just going to move on, continue to the next example. I think it's going to be arguments. Arguments is the one that I did. So the last one is buffer. I'm gonna see if I can do this on main directly. It's probably not gonna work because it requires a library. And if I remove, then it's just gonna be the same. I think for these kinds of examples, it's probably better to use x64 DBG as well. But I know from previous code that I've seen that it's just gonna call the function. And I think that it doesn't show the code from the function. So probably I'm just gonna skip this one, and maybe at some other point I'm going to see if I can study the source code of these functions. But I think for now it's probably not worth it. So the last examples are the JSON Turner ones, and I didn't do all of them because on the video that I took this from, he does a bunch of variations on the same file, and I didn't want to do all of them because there's a lot. So I think that I don't know why I separated. I guess yeah, there is like this main two here. So there's the lambda, the struct, and the equivalent. But I'm not sure if this one's better to just put everything on the same file. I think I should probably watch the video again and see how he does it. But I don't think he's using Compiler Explorer to. It's basically a video where he talks about everything you need to know in C++. And then he goes over variations. I don't remember where is the video exactly. I can't find the video, but it's on this channel here. I don't remember which one it is. No, I think it's exactly this video. Yeah, it's this video here. He goes over a bunch of variations of this stuff. And then he writes down the concept here. So maybe these ones are... The problem again is that it's too much. So I think for these kinds of examples, it's just better to like then take some time. So I'm probably gonna do like after so I'm gonna focus on... I'm gonna build the Anki cards with the simple examples that I have there. Then do the Anki cards as I study Haskell offstream and go back to Godot. Then once I finish the stuff, the scene on Godot, I go back to studying this other stuff. I'm gonna focus more on compilers and probably on Haskell as well. And then maybe after I study a bunch of other stuff, like all these things, then I go back to this thing here and I take some day to just spend a bunch of time studying the I'm probably gonna go back to the video again and then just do all the variations of the examples that he talks about there. Or it might be a good idea to like take a day for just watch as I watch the video, I put the stuff that he talks about on the Compile Explorer, and then I spend a bunch of time trying to understand how it works on assembly. So I'm not gonna do this one. I'm gonna stop streaming now. So yeah, and I'm going to put this because, like I said, I don't have a lot of time, and there's a lot of other stuff that I have to do. So I'm just gonna pass all of this into create Anki cards for all these examples on green. And I'm not gonna think about this stuff. I'm just gonna try to probably gonna do try to do 15 minutes every day or something like this, or maybe even 10 minutes or even lower, just to have a consistent baseline of cards that I do, Anki cards that I do every day for the examples. So I have two main things that I'm doing there. One deck on Anki is for the nuances, so like the flags on the instructions, to memorize when each jump is gonna happen, what flags the jumps require, the calling conventions and stuff like that. And then so it's basically these two main decks here. This one is the one that has the nuances, just this stuff. And this other one, fundamental patterns, is the one that I'm gonna create now. So the front of the card is gonna be the C++ code, and the back of the card is gonna be the assembly code. So I'm just gonna do for all these examples here. And once I finish creating all the examples, then I'm gonna start the Anki stuff, and I'm not gonna think about this until I finish all the other stuff. And I'm probably only gonna come back to this once I feel like I have done like a bunch of examples and I remember I have the fundamentals down very, very well. Then I think it's gonna be a good time to go back to this, like after I learn everything else and I finish the scene. Then I think it's probably gonna be a good time to go back to this and dive deeper into the more complex examples. But yeah, in the beginning, I think it's always better to focus a lot of time on the fundamentals, the basics. So until you really memorize everything. So I'm gonna stop here. So probably next time that I stream, I'm going to continue the Godot stuff that I stopped a long time ago. So I'm gonna spend time probably studying the VS Code source code to understand how they load the files here, because I have to figure out how to make the Godot components, the Godot's file system or file system doc components. I have to make it faster to load big directories, because right now it's very slow, and I have to figure out what happens. So I'm gonna go back to that stuff and then I'm gonna do this other stuff off stream until we finish the scene there. Then I'm gonna go back to these things here. So see you next time.